this problem is presented the hydrogen atom, so the electron is rotating around the positively charged atom core, and needs to show that the dipole moment has such a form. From the pink pages, from the page 8 is this equation for the dipole moment, electric dipole moment, and it's written that this Q is actually charge of the netto charge of the moving negative charge, and delta X is distance between positive and negative charges. So it doesn't have the shape of the form of this, but we can try to come to the form. First of all, the dipole would be, even here I marked the direction of R in that direction. The dipole would be directed in opposite direction, from minus to plus. Q, netto charge of the electron, is elementary charge. And then this displacement between these two charges is R, but it's minus R. And then it's equal to some R in R direction. And the electron is rotating, so there is an angle phi between X axis. And this angle phi is a time dependent, omega t. So you know that R is also dependent of omega, not of omega, of phi. We can rewrite it. So R would be some magnitude of the charge of the distance between, of displacement, and then unit vector is cosine phi plus y minus phi, and then it becomes phi that minus cosine omega t minus plus y sinus omega. So we got closer to this form. Now we have time varying omega t component, and if we describe a sinus as cosine of placed by 90 degrees, the form of the gets the following form. And now there is, from the theory, now going to this analytical representation of oscillating harmonic oscillation, where for the real numbers, the cosine of this cosine is equal to this Euler number, this exponential, and now we can use it for this equation above and rewrite it. and then there is pi times 90 degrees, or pi divided by 2 with a minus. And now we can take this exponential out of the brackets. So what will be this? Sin pi. Half pi, and then this is 1, and this is 0. So we get I in one direction. That's it. That's the answer. And of course, in this representation, this is, okay, I can rewrite it better. So this part is P naught of the dipole moment. So that's the shape of the shape of the equation above. And for regarding the B question, so the B question asks to tell how such atomic model in classical electromagnetism should generate radiation. It's a dipole, yeah. Question is about radiation. However, in the bracket is written that only quantum physics, no, according to quantum physics, there is no radiation from hydrogen in the ground state. So according to the classical electromagnetism, there should be generated radiation, but there is no explanation of the atomic structure in the classical electromagnetism. This is what the quantum mechanics does. And by the classical electromagnetism, electron would lose at some point the energy and then just be attracted and fell on the surface of the atom core, which doesn't happen in life. So classical electromagnetism doesn't explain atom structures.